class, this is Coach Riza. For today, we are going to talk about the universe and the solar system, part 2. Last time, we have discussed about the universe, how it all started, and the theories that explains the expansion and development of our universe. In this video, we are going to talk about our solar system. But before we proceed to our main topic, let's find out first the size and the scale of the universe. So have you ever wondered gaano lang ba kalaki or kaliit ang planeta natin? Ayan. So our planet Earth, no? Ang ating tirahan, ang ating tahanan. So gaano nga ba tayo kalaki or kaliit in this vast universe? So we have this quote. Ayan. We are nothing more than a small speck of dust in this vast universe. So the universe is really vast, and there are a lot of things that is not yet discovered by our scientists. There are a lot of bigger planets out there, and for today, we are going to find out, how big or small our planet versus to other planets within our solar system, and of course, versus to our vast universe. So let's see. So this is our planet Earth, and we are there somewhere out there. Yan. So of course, we are in the Philippines. That is why we are there, somewhere there. Okay? And this is the usual or typical illustration of the planet Earth. Ito yung palagi nating nakikita sa mga pictures, and sa mga images, from our textbooks. Okay, but let's find out, gaano ba to kalaki itong ating planeta in a model scale or in a small model scale of illustration of our planets. Okay, so the first batch is this one. Ayan. So we have here 4 planets and wala pa silang pangalan. So we have planet number 1, planet number 2, planet number 3, and planet number 4. So, take a guess, which is our planet Earth? Of course, we all know which is the planet Earth. But take a guess, what are the names of these planets? These 4 planets, okay? So I'll give you a few seconds to think about each planet or the name of each planet. May sagot na ba kayo? Okay, sino kaya si number 1, number 2, number 3, and number 4? Ayan, so let's find out. Ayan na. Ayan, tignan natin kung tama ang sagot nyo. Okay, so planet number 1 is Mercury. Okay, so it might look like a potato to you, but it's not a potato. Okay, hindi siya patatas. Mukha lang siyang patatas. Pero Mercury po yung planet number 1. Planet number 2 is the Venus. Ayan, si Venus. Ganda. And planet number 3 is the Earth. Of course, our home planet. And planet number 4 is Mars. Okay, so as you can see, each planet has different sizes. And hindi siya yung typical na nakikita natin from our illustrations or yung mga illustrations na nakikita natin before. Okay? So this, again, is a hypothetical model scale size of our planet. Okay? Of our planets. So, tingnan natin, let's focus on our planet Earth. Ganyan siya kalaki versus the other planets, the first 4 planets. Paano na kaya or gaano na kaya kalaki ang ating planeta if we compare this to the 4 remaining planets in our solar system? So let's see. Okay, let's see. Okay, so here is the second batch of our planets. Okay, again, take a guess. Which planet are the names of the planets? Okay, see planet number 1, planet number 2, planet number 3, planet number 4, planet number 5, and planet number 6. So, ano kaya yung mga names nila or sino-sino kaya itong mga planetang ito? So, I'll give you a time to think about it. Okay, think of your answer and the timer starts now. May sagot na ba kayo? Ayan. So, ready na ba tayong malaman kung ano yung tamang names ng mga planets na ito? Ayan. So, let's find out on our next slide. Sino kaya ang tumama? Okay. Here it is. Okay. So, number 1 is Jupiter. Ayan. So, yan si Jupiter. Number 2 is Uranus. Number 3 is Neptune. Number 4 is Saturn. Number 5 is Pluto. Take note, it's not a planet anymore, but a dwarf planet. And its moon, the tiny little red dot somewhere there, is the moon of our Pluto, which is Charon. And then the 6th planet is our planet Earth. So just take a look at that. Our planet Earth a while ago is a bit bigger than like this. It was bigger, no? Versus the other 3 planets. No, yung first 3 planets natin. But when we compare this to our planet to the last 4 planets, lakas makapangliit moment. Our planet Earth is this little cute planet here beside Jupiter. Imagine, no, ang lakas makapangliit ng ating existence, no, in our planet Earth. Jupiter is really big. Saturn also. Ang laki nila, no? Ang lalaki ng mga planeta na sa ating yung last 4 planets natin. Except for Pluto, of course, it's a dwarf planet. Okay. So, now you see, no, kung gaano kalaki or kaliit lang yung planet Earth natin. Hindi ito yung typical na nakikita natin, no, yung sa illustration or yung illustration na nakikita natin sa mga books. Okay? So, it's different. No? Hindi kasi yun yung actual sizes. But this, no, came from a source that I've got. And this is the model scale size of the planets, no? Para lang makita nyo, ano ba yung size, no? Ano ba yung itsura ng planeta natin, no? In a model scale. So, this is a model scale based from the original sizes of this planet. Okay. So, lakas makapangliit moment. But, take note of the appearance of our Jupiter. Let's find out naman kung gaano kalaki ang mga planetang ito versus our Sun. Okay, so wait, there's more. Paano naman tayo or gaano naman tayo kalaki versus sa ating Sun? So, take note of the appearance of Jupiter. So, si Jupiter ang gagamitin natin pang-compare sa Sun natin. So, moving on to the next slide. Here it is. Ayan! So, look at that. Jupiter is this little planet here. And as you can see, this little planet here is our Jupiter. Imagine the size, the difference versus our Sun. Again, the Sun is the nearest star, no? It's a star. So, ito yung pinakamalapit na star sa ating solar system because it's within our solar system. Okay? So, imagine this is our Jupiter versus the Sun. But a while ago, as you can see, no, Jupiter is really big or bigger, no? One of the biggest within our solar system. And look at our planet Earth. Okay? So, ganito lang tayo kaliit. Tapos, si Jupiter, ganito lang siya kalaki versus our Sun. So, lakas makapangliit talaga. Lakas makapangliit ng size, no? Ng ating planet. Okay. So, now, you have seen the size or the scale of our planets. So, how about our planet Earth versus the universe? Gaano lang ba tayo kaliit, no, in this vast universe? Sabi ko nga, wait, there's more. Okay, here it is. Ayan! Realms of the universe. Napakalawak po ng universe natin. At napakaraming bagay pa na hindi na-discover beyond sa mga na-discover na. But here is our planet Earth. As you can see, this is our planet Earth. And as I have said, it is just a tiny little cute planet now within our solar system. And nakita naman natin yung scale or size, no? Sizes ng mga planets natin kanina, no? Again, this is just an illustration. It is not to scale. Hindi to yung eksaktong scale nila. But I've shown you a while ago, diba? It's different. Their sizes are different. But this solar system, or our solar system, is just a tiny fraction of this Milky Way galaxy. We are within the Milky Way galaxy. This is our galaxy, and our solar system is just a tiny part of this galaxy. Okay, so napakaliit pala natin. No? Somewhere there, andun tayo, yung solar system natin. And within our solar system, andito tayo sa third orbit na ito. Ayan, our planet Earth. And take note, class, that Milky Way galaxy is a part of a local group of galaxies. So, marami tayong kapitbahay pa, no? Nakalapit itong si Milky Way galaxy. And take note again that this local group is just a part of a local supercluster. So, napakarami pa pong clusters of galaxies, no? And of course, beyond that, napakadami pa talaga, no, na hindi pa na-discover, no, in this vast universe. Ayan. So, napakarami pang hindi pa na-discover beyond this universe. Okay? As you can see now, this is our scale, no? The size and scale of our planet Earth versus our planets and versus the universe. Ayan, lakas makapangliit moment. So, if you're feeling na medyo, okay, you are having existential crisis ba? Di naman, wag naman sana. Here is my hugot for you. Don't take stuff so seriously. Remember, you are there, you are here, somewhere within this galaxy. Okay, we are there, somewhere there in this galaxy, our Milky Way galaxy. We are living, we are alive in our planet Earth. And let's just be thankful, no, that we are alive and we are living. Okay? So, yan. So, wag masyadong problemahin yung mga problema. Ayan. The universe is really vast. Ayan. And let's just be thankful that we are alive. Okay. So, next, no? Ayan, move on na tayo to our topic. Ayan, move on din pag may time. Okay. So, this is our main topic for today. Our solar system. So, as I have said a while ago, no, I've shown you the size and scale of our planets. Ito yung tinutukoy ko na illustration, no, yung typical illustration na nakikita natin sa mga science books natin. And again, this is just an illustration. It is not the original size of our planets and our sun. So, it's an illustration for us to know, no, that this is the solar system. So again, we have here the first 4 planets: Mercury, Venus, Earth, Mars, an asteroid belt in between. Okay, we have here Ceres. Ceres is a dwarf planet. Next batch of planets is Jupiter, Saturn, Uranus, and Neptune, and they are our giants or gas giants. Okay, so we also have here another belt of asteroids, and we have here Aries. Aries is another dwarf planet. And beyond this, there are a lot of planets that has been discovered throughout the years. But again, this is our solar system. No, meron pa beyond. Okay, so parang nandito pa ata si Pluto, somewhere there, but hindi na siya kasama sa picture na ito. So, si solar system, as I have said, no, is our main topic for today. And si solar system daw ay may mga features. Ayan. So, may mga features siya na tinatawag. So, we have a large-scale features of the solar system and a small-scale features of the solar system. So, let's find out what are those features, no? Yung features ng ating solar system. So, this is another illustration of our solar system. Again, this is not the actual size. Ayan, illustration lang po siya to show our solar system. Okay, so let's first discuss the large-scale features of this solar system. First is the mass. Okay, much of the mass of the solar system is concentrated at the center, where the sun is. Ayan. As we have seen, no, our sun is the biggest of all the other entities in our solar system. So, of course, since it's bigger, it's heavier. That is why the mass is concentrated at the center where the sun is. While the angular momentum of our planets is held by the outer planets. Okay, the angular momentum of our planets again is held by the outer planets. Orbits of the planets, ayan, as you can see, is elliptical and are on the same plane. So, elliptical siya, paikot siya. Okay? And it's on the same plane. And all planets now revolve around the sun. So, the periods of revolution of the planets increase with increasing distance from the sun. Okay? And the innermost planets move faster and the outermost are the slowest. Ayan. So, habang papalayo, no, yung rings, no, yung ating orbits, no, yung distance between the planets from the sun, no, pa-increase din yung revolution or periods of revolution. Of course, it's because malayo na yung iniikutan niya, no? Yung orbit or yung distance na iniikutan ng planeta natin. So, yung mga innermost planets natin, medyo mabilis konti compared dun sa ating outermost planets. So, mas malalayo na sila, mas malalayo din or mas matagal din yung pag-revolve nila around the sun. Okay, so all planets are located at regular intervals from the sun. So let's move on to our small-scale features of the solar system. First is, most planets daw rotate prograde. Ayan yung rotation naman ng planet natin. Okay, when we say prograde, it means counterclockwise when viewed from above the Earth's north pole. So, kung ikaw daw ay nakatayo at nag-observe kung paano mag-rotate ang mga planeta, no, sa North Pole, makikita po na ang pag-rotate ng mga planeta ay counterclockwise. So, yun po yung prograde. So, most planets rotate prograde. So, the innermost terrestrial planet are the Mercury, Venus, Earth, Mars. So, yan po yung inner terrestrial planets. Okay, so yun yung tawag sa kanila. While the outer four planets, Jupiter, Saturn, Uranus, and Neptune, are called the gas giants. Tawag sa kanila gas giants or Jovian planets. So that is our small-scale features of the solar system. So lahat mo ng mga nasabi kong features of our solar system are all written here. Ayan. So let's see. And so the large-scale features of the solar system, as I have mentioned a while ago, and the small-scale feature of the solar system. So kindly read na lang our PDF file of this lesson. Okay, so let's move on to our next topic. Our main topic for today is the origin of the solar system. So, kung si universe, no, meron siyang pinagmulan, of course, our solar system also has its origin. And there are a lot of theories, hypotheses, ideas, no, na nakam up yung mga scientists natin and mga ancient philosophers regarding sa origin of our solar system. But we are going to talk about 4 of those. Okay, yung 4 na hypothesis or theories na na-propose ng ating mga scientists. So, let's find out now those 4 ideas na given by our scientists. So, first is the Nebular Hypothesis. Okay, so in the 1700s, Emanuel Swedenborg, Immanuel Kant, and Pierre-Simon Laplace independently thought of a rotating gaseous cloud that cools and contracts in the middle to form the sun and the rest into a disk that become the planets. So, tingnan natin si Nebular Hypothesis. So, sabi niya, meron daw rotating gaseous cloud, okay, that contracted, cooled down, and contracted. And of course, due to self-gravity, it contracts, forming the disk, rotating disk. And in the middle of that rotating disk formed a proto-sun na tinatawag. Okay, our sun. The central mass forms into proto-sun. And the rest of the remaining gases within that disk formed into rings and then formed into a planet. So that is our nebular hypothesis. No? From a rotating gaseous cloud, it cools, contracts, in the middle form the sun, and the rest into disks that become the planets. Again, nebular hypothesis, same lang naman yung explanation, iba lang yung illustration. So here, a colored illustration. As you can see, the rotating gas here, and then it flattened. The second part, it flattened, and then a mass formed in the middle, and it formed into our proto-sun. And the disks were formed, rotating disk, and then from that disk formed the planets. Yan. So that is our nebular hypothesis. Next is encounter hypothesis. In this theory, a rogue star passes close to the sun about 5 billion years ago. The material in the form of hot gas is tidally stripped from the sun and the rogue star. As the material fragments into smaller lumps, it forms the planets. So let's find out now this encounter hypothesis. So paano ba yun nangyari? So here is our illustration of the encounter hypothesis. As I have said, meron daw napadaan na rogue star malapit sa ating sun. And because of that encounter, the gas on both sun and star gas is tidally removed from both the rogue star and the sun. And that gas, the hot gas, formed into our planets. Okay, from that simple encounter, a rogue star passes close to a sun, na-strip off yung mga gas, and from that, na-form yung mga planets natin. That is our encounter hypothesis. So, nagkaroon lang sila ng encounter. And then na-form si planets. Now, encounter hypothesis, or this hypothesis, has the advantage of explaining why the planets all revolve in the same direction, and also provides an explanation for why the inner worlds are denser than the outer worlds. However, some major flaw can be pointed dun sa encounter hypothesis natin. First is, since it's a hot gas expands instead contracts. So lumps of hot gas would not form into planets. So if you could still remember from our lesson 1, if I explained lesson 1, part 1, about the Big Bang Theory, nung time kung saan ang universe natin ay super hot, and it's a super hot gas, or in a super hot gas state. So I have mentioned that with the presence of heat, there's a presence of energy. And the particles of matter, the gases, has energy. And because of that, they tend to expand. They tend to move because they have energy. So, ito yung ina-explain sa atin na major flaw ni encounter hypothesis. Dahil ito ay in the form of hot gas, hindi ito magko-contract. Hindi ito magka-clump together to form planets. Dahil ang tendency ng mainit na gases ay to expand. Gagalaw lang sila because they have energy. So that is one of the major flaw. The second one is the chance of encounters between stars are extremely rare. So rare as to be improbable in the lifetime of the universe. So kahit daw matapos na yung lifetime ng universe, hindi daw mangyayari yung encounter na ito between a sun and a rogue star. So, hugot lang ni Ma'am Jan, hindi na pinagtagpo, hindi pa ay tinadhana. Ayan, so nakahugot din si Ma'am Shi sa video na ito, So, yun po si encounter hypothesis. So, hindi siya talaga itinadhanang mangyari. Okay, so next is the collision theory. Proposed by a French naturalist, Georges-Louis Leclerc Comte de Buffon in 18th century. Ang haba ng pangalan niya at hindi ko sure kung tamang pronunciation ko. But ito yung sinasabi niya regarding kay collision theory. Planets daw were formed by the collision of the sun with a giant comet. So the resulting debris form into planets that rotate in the same direction as they revolve around the sun. So yung mga planeta daw natin ay nagmula sa mga debris or natipak na debris, no, dahil sa collision ng isang giant comet sa ating sun. Okay, so tingnan natin, no, ayan, ganito yung itsura. Paulit-ulit lang yan, kasi GIF siya. Okay, so ganyan daw po yung nangyari. Collision of a giant comet to our sun, causing the debris not to form the planets. Okay, so that is our collision theory. Last but not the least is the protoplanet hypothesis. So, the protoplanet hypothesis says that contraction of slowly rotating gas cloud dominated by hydrogen and helium due to gravity that later form a cloud of rotating disk. So, most of the mass moved to the sun, creating the protosun, and the remaining materials form a disk and eventually become the planets, and momentum is transferred outwards. So, the protoplanet hypothesis, the first part of the protoplanet hypothesis kind of reminds us of the Nebular Hypothesis, right? So, medyo huwig siya kay Nebular Hypothesis. But, the thing added to protoplanet hypothesis is that there is a collision happened, or may nangyari mga collisions. Okay, so collisions of other fragments and other solid matter form larger bodies. Okay? So, dahil sa collision, no, na-form yung larger bodies called the protoplanets. Yan. So, protoplanet hypothesis also has flaws. First is the angular momentum. Hindi ma-explain ni protoplanet hypothesis kung paano yung angular momentum ng mga planeta and the mechanism of disk that turn into planets. But, the protoplanet hypothesis is the current working model for the formation of the solar system. So, ito po yung current working model, no, that explains the formation of our solar system. So, ito po yung itsura niya. Ayan. So, ito po yung illustration regarding our protoplanet hypothesis. Paano ito nabuo? So, same explanation in a different way. That time daw, a Milky Way galaxy is filled with cold clouds of molecular hydrogen gas and helium, also filled with dust. So, dust provides sites for condensation of gas. So, it's ice-covered dust, and the cloud begins to collapse under self-gravity, and dust begins to accrete. It means to say that due to self-gravity, the dust clumped together, no? Clumped together, forming the rotating disk. So the clouds collapsed to a rotating disk, and that rotating disk at the middle formed the embryo sun. So na-form yung ating embryo sun at the middle, and the rest formed into our solar system disk. Okay? And from that solar system disk, or from that disk, form our planets. And as I have said a while ago, there also some collision happened that formed the other planets. So that is our protoplanet hypothesis. Okay? So it is the current working model for the formation of the solar system. Is everything clear? Any question? If you have any question, just chat me on via Messenger or via LMS chat box. Thank you for listening. I hope you've learned a lot. Reminders: read and review our lessons, watch all video links, answer all activities. It's all posted at Module 1. Please do this during your asynchronous schedule for ELS. Again, thank you and hope to see you in our next class. Bye!